Okay, last time we described the MoveLeft function. Now we're going to move on to the MoveRight function, which is very, very similar. Remember, MoveRight, MoveLeft, and RotatePiece are all part of, are contained in, or are sub-functions of the ProcessInputs function. That's where you find them. RotatePiece, MoveLeft, and MoveRight are all secondary functions, so they don't appear in the main loop. They are sub-functions of the ProcessInputs function. Okay, the ProcessInputs function being a primary function, and therefore it occurs in the main loop. Okay, so let's get on and program the MoveRight function, which you might have guessed is very, very, very similar to the MoveLeft function. Okay, so if we're moving right, we want the same kind of function, very, very similar. We either want it to be successful, we either want it to be okay or successful and work okay, or we want it to fail on certain conditions. Those conditions are if there is a block to the right of it in the way, then it can't move right, or if it has reached the right of the game board, then it can no longer move right. Okay, well, I'll explain this a slightly different way. Okay, so that's for moving left. So if I copy that and put it in the MoveRight function, and then instead I put +1. Okay, now it will move right. Okay, so move down works okay, move left, move right, and array index out of bounds. Okay, and it's giving me a debug message because I have debug turned on. It's saying it's out of the array index out of bounds, which means it's gone outside of the array. Okay, and that's another reason why in MoveLeft we put like that. Okay, so it never ever goes out of the array. Okay, so for the piece we want to check from the right. Okay, so here's our piece, it could be any piece, and we want to check from the right. So we want to check from here to here. Okay, for the X iteration. Okay, the Y iteration we can check either way, but we might as well go from 0 to 3 for the Y iteration. Just makes it easier, slightly easier. It's not really difficult. But for the X iteration, because we want to check this side of the shape, it can be any shape, I want to check this side and check it doesn't bang into the sides, or when it bangs into the sides it stops, or if it bangs into a piece to the right of it, it also stops. Okay, so we check 3, 2, 1, 0 for the X iteration. So we're going to go 3, 2, 1, 0, 3, 2, 1, 0, 3, 2, 1, 0, 3, 2, 1, 0 for every piece for the MoveRight function. Okay, and a little thing I forgot to mention, which should be obvious by now anyway, is that the current piece X and current piece Y are actually these positions here. Okay, so that's cur piece X and cur piece Y, which I forgot to mention last time, but it should be clear anyway from previous tutorials. Okay? Okay, so we check the X iteration first, same as last time, because that's the one we want to check first, otherwise the piece might get stuck on the side or whatever. Okay, so we check the X iteration. X iter equals 3 to 0, step minus 1. Okay, and then we check the y iterations. For all the y iterations, 0 to 3. Okay, and then we check if the piece is not equal to 0. Okay, if a block in the piece is not equal to 0, i.e. it's full, remember this is 0, this is 1, so we're checking these pieces here. We're checking it's not equal to 0. All the other blank spaces are equal to 0. Okay, so that's that piece, exactly the same. Then we have to check, same as we did for MoveLeft, that it hasn't gone outside the game board. Okay, for MoveLeft, it's the highlighted piece here, it's this piece here. So we can Control C this, and we want it to check the right hand side. Okay, so remember it's the current X position of the block plus the length, and then plus 1, not minus 1, is equal to 10. That's 9 plus 1, or equal to 9 plus 1. Okay, because it's 0 to 9 across the top of the board. Okay, 0 to 9. Okay. Okay, but I can just put 10 here, and that's when it reaches the edge of the board. Okay, and I'll show you where the plus 1 comes from as well. Okay, so if we look at the board, okay, the Tetris piece, here's one example. Okay, so we want the red dots, yeah, they're 0 on these particular pieces. Okay, so, and the green dot is current piece X, current piece Y. Okay, so we start here in the middle. Remember we started at 3, 0 for the board, current piece X, current piece Y, which is that green dot, and then we move down, drop piece, we can move left, but we're moving right, we want to check right, and we want it to stop about here. Okay, so that's plus 1 beyond the edge of the board. Okay, and it's the same for this one here. The green dot is current piece X, current piece Y, so it will start here and drop piece, and then we move to the right. We don't want it to stop here, we want it to stop here, so we add 1, okay, to the current piece X and the width, which is X iter, and then we add 1 because we want it to go beyond that. We want to check just beyond that. Okay, and it doesn't matter what piece it is. Okay, if we have a piece like this, it still doesn't matter, because as we go down, drop piece, move right, when it gets to here, this is not equal to 0. Okay, so it can't move, because we're going to check this as well, just like we did with the MoveLeft function. Okay, so it can't do this, because this, where that red dot is, it's not equal to 0. So even though you got current piece X plus the X iteration plus 1, it's still, because it can't move, because this one is not equal to 0. Okay, so we'll cover that as well. Okay. Okay, I could have very easily just put this, but it makes it more difficult to understand. If I put it like this, then it makes it easier, since we're going to substitute it into the board position as well. Okay, and we want it always less than. Okay, so it hasn't left the edge of the board to the right. Okay, because all these numbers are lower, so it's here or somewhere here between here and here, and then it stops here. Okay, same for this piece. It's somewhere between here and here. So it's always less than, because we're counting down as we go from right to left. Okay, so we can simply substitute in the formula. I will copy Control C, and we need to check the board as well. Okay, so we've checked the piece and we've checked the position. Now we need to check the board, and we simply substitute in this formula here for wherever it is on the board and put that into the formula, and we're just checking as normal. We're just rotating through the pieces, going through the rows, the Y rows. Current piece Y plus the height of it, Y iter. These things are not case sensitive. The variables are not case sensitive, but try to follow the same convention. It makes it easier to read. Then return. Okay, and then it's the same logic as before for the MoveLeft function. Yeah, any other condition we also want to return, and we'll Control C and we'll just put that in there, and then we are done with the MoveRight function. Okay, remember it's return and not return false and return true. It's just return for both the MoveLeft and the MoveRight functions. Okay, so they're very, very similar. The only difference is here and here and here compared to here, and this bit here and this bit here. Obviously the substitution as well follows here and here. Okay, so they're very, very similar. Okay, so let's test this out. Okay, drop piece, move left, move right. Okay, and I can't go any further. I keep pressing left, keep pressing right, keep pressing left, keep pressing right, and down. And of course it doesn't place the piece because we haven't done place piece yet. Okay, so that's pretty much the MoveRight function. We'll be moving on to put a delay or a repeat delay. That means when you run it, we've got a square this time, it doesn't go whoosh to the right or whoosh to the left. It sort of goes duh, 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 because it's too fast at the moment. So we're going to put in a repeat delay, and we're going to go back to the ProcessInputs function to do that in the next tutorial. Okay, so this ProcessInputs function, we're going to go on to part B, and we're going to use the repeat speed and repeat delay. These are what these are for. Okay, it's very similar to the drop speed, drop delay. Okay, but it's not going down, it's going left and right. Okay.